So as I mentioned here, for those of you watching this online, I'm not going to be here on Friday. And so I think what we'll do, we'll just push the test back to Wednesday. And that way we can go over stuff Monday if you have questions or after the weekend. Okay, so we'll just plan on that. All right, so I've handed out a test review here, and it looks something like this. So the first thing are the topics. So this covers 3 chapters and no more. So it just covers what you've got on that list. So volume, weight, and then density is important there. Specific gravity is important. Viscosity and vapor pressure, we just kind of discussed generally. We didn't really do any calculations with that. We just discussed them. So you should just know what they are, basically. Okay, then we did pressure, where pressure is force over area. And then being as we're mostly dealing with water in this class, we looked at the relationship there between pressure and depth of water. We have those numbers there on the formula sheet. Now keep in mind when you do this little test, you'll get a formula sheet, okay? So you want to be familiar with that, so have a look at it, okay? And then we did atmospheric pressure, and remember those conversions between different types of pressure for a vacuum, okay? So we did that. So we did gauge and absolute pressure, and then we did, vacuum measurements using. So those all kind of relate to atmospheric pressure a little bit. And then we did a few kind of special topics on this, well depth with those well depth, those bubble gauges and things like that. We looked a little bit at burden gauges, how they work. And then we talked about manometers, those U-tube manometers that connect 2 pipes together. Okay. And then the last chapter there was force, which is weight, which also is pressure times area. It's usually the average pressure that you would use there, so keep that in mind. And then we had those 3 special topics, hydraulic jacks and buoyancy and thrust blocks. Okay. So that's the list of topics that I picked from. The things that are important that I definitely want you to know are, let's see, what are they? Well, we put stars next to them or something like that. Come on, get over here. There we go. I definitely want you to know density and specific gravity. I definitely want you to know that pressure is force over area, and that these constants, what to do with those things. And I want you to know that force equals weight. And, well, more particularly, how about this one? Force is equal to pressure times area. So those are, what I mean? Those are things that I'm definitely going to cover on this thing, okay? Okay. And then the other things I'll kind of pick and choose from. I can't put everything on the dang test, it's too much, so kind of pick and choose, okay? So we kind of clear on what I'm saying there with that? Okay. Yeah. So those are things, that I would definitely cover.
We have lunch at the restaurant now.
Yeah, the service is
We're gonna smoke right there.
So no leftovers, no doggy things?
We were gonna bring you bread, but I ate it. Yeah, I would eat it.
Is the service really slow there still?
A little bit.
A little bit.
Right, they're first years serving it. So.
Yeah.
We actually even got in there early.
Yeah.
Then they took the time.
Okay, I'm going to be out on Friday, so I think I'll push the test back to Wednesday so we can cover stuff on Monday. If that all makes sense. Okay.
So this Friday?
Yeah, I'm gonna be gone, so it won't be class. Chad?
Yeah, she'll be this Friday.
James?
Oh, I haven't got nothing.
James is over here.
Oh, it's all good.
Still working on this.
No worries.
Better.
I got 20, but weird,
Oh yeah, I don't know those either. Must be in the right. I don't know.
So we're just going over this little test review tonight. I got it. Okay, so what we got here, I just went over the topics, the things with the red stars next to them. Those are topics that for sure will be covered, all right? So those are the important things, and important things find their way onto the test. How that works. Should work anyway. So we're good with that? All right, now on the back of this handout, what I've got are just some example problems. Now, don't take too much of these. Don't just say, oh, I can do those, so I'm good on the test. They're just kind of examples of what it would look like, okay? They look like homework problems, okay? But I'm not saying it's specifically going to be these problems. I'm just, I just threw them on here. I just picked them off an old test. Okay, all right, so number one there, we got a person using a straw. And there's three people. They were having a contest who can pull the stuff out of the cup the highest with the straw. And I want to know who's going to win. Okay, person in the beach in Samoa, person at LBCC, or a person in the Himalayas. And I'd like to know why, okay? And we'll cover these on Monday, just everybody think about it a little bit. So what I might have on this test are some little short answer questions, sometimes I do that. We got a multiple hydraulic jack. Which piston would exert the largest force? So notice on this that A, we're pushing down, and that we're going to push up at B, C, and D. So which one, as we're pushing down at A, would exert the largest force? Which one would move the farthest? Okay. So those are just some things to kind of think about a little bit. So I might have a couple of those. So we good with that? Okay. Find the pressure in the pipe. The fluid has a specific gravity of 1.21. Okay. And I'll see if I get the answers for these up on Moodle maybe later today. Why don't I try and do that? 7 inches of mercury vacuum equals how many psi G and how many feet of water barometer? Okay. So on that one, remember we used that chart. Now the chart's on the formula sheet if you need it, okay? So remember that. Just have a look at the formula sheet. Just be sure you know what you got on there, because it's good to know.
Are we going to get a formula sheet for the test?
Yeah, absolutely. Yeah, I'll get you a new one of those, okay? All right. Find the force on the window. Okay, watch your units on that, right? So, just be a little careful of units when you do that. What's the pressure difference between the two pipes in PSI? And I give you the specific gravity there of mercury, which is what that fluid is. Oh, we got one more. The fluid in the tank weighs 4,262 pounds. What's the specific gravity of the fluid? Okay. we go. Okay, so on those example problems, did we cover density? I think we did on that last one, and specific gravity. We covered pressure. P equals F over A, a little bit there. And then we got pressure and depth of a fluid. These constants here are on your formula sheet. And then we had a force problem, right? So yeah, that's kind of how that stuff might be covered. All right, so this one, you got to know the relationship between depth and pressure, and specific gravity. This one here, you have to do the conversions using that chart. There's find the force on the window. Remember, watch your units on that one. And then this again uses specific gravity and the height to pressure relationship. And there's specific gravity, okay, and density again. All right. What I'm thinking, maybe I'll just leave this with you, and I'll see if I can post the answers. We go over anything on Monday if you got questions. I mean, maybe just do it that way. Or do you have any questions currently on that? All right. Okay. All right. So just so Monday, if you got questions, we can do it. And then that test will be on Wednesday. That's all we'll do on Wednesday.
How big do you think the test will be?
Well, I don't know. Typically in the past, I don't know, I've had one page with kind of short answer stuff, and then maybe 4 other problems. I'm just trying to remember. It's not like a time issue. Most people don't have a real issue with, having to go fast or anything like that, from what I remember. So, whatever that's worth. Okay. Okay. Why don't we keep kind of moving ahead here? So let's see. Now I did assign that Q equals VA stuff, right? I made it do the Wednesday next week, so that'll move back to next week Friday now, okay? Because I'll make that do the day after, or the class period after the test. I guess Friday won't work too well though, will it? Being as a lot of you aren't here, so I'll push it back to Monday. But get on the thing, okay? Because I don't want you to be waiting too long on doing that stuff. So
That was chapter 9, right?
yeah, let's just get into Moodle and have a look. It was chapter 9. It was 5 problems in there. The first 4 on one page, and the one after is on.
Chapter 9 is on Monday?
Yeah. I guess we'll just do that. But I'm just doing that so it conveniently works out for everybody. Let's see. Turn editing on. I thought I'd done this, but okay. So you got all the answers for them here. Why can't I cut that? Because I didn't edit. Is that why I can't? Yeah, I think so. Cut. So that's Monday. I don't know. Okay, go back to 16. Is that the 30th? I think it is.
Next Friday is the 27th.
Yeah, so 28, 29, 30. There we go. So we're good. So it's the Monday the 30th. Yeah, I will make it do Monday because there's people who don't come on Monday. Okay. All right, so again, we can go over this one a little bit more next Monday, okay? And no class on Friday. Open. All right, so we're back on Bernoulli's equation, as it's called. Okay, so all right. Okay. So Bernoulli's equation is this thing that this Italian Renaissance scientists came up with a long time ago. And it's just a way to analyze piping systems for us is what we use this for primarily. So I'm on page 101. So it's pretty straightforward. I mean, all that he was saying there is if you take the original energy, subtract off the head losses, you'll get the energy at the next point down the pipeline. That's basically what he's saying. Now, the energy is the sum of elevation, pressure, and velocity head. So here's where it starts to get more useful for us if we're analyzing systems. So if you take the elevation A plus the pressure head at A plus the velocity head at A and subtract off the head loss that occurs from A to B, you'll get the sum of the elevation at B, the pressure head at B, and the velocity at B. That's basically what this says. And you can use this to analyze things. Okay, and I've got this thing on your formula sheet too. So let's figure out from this problem here what we would predict the pressure would be at point B. Okay. So let's get that worked out. All right, so what we've got here is we know what's happening at A. And to really use this equation, you need to know the starting information. So what we got here, we got 100 psi here. And we want to know what's the pressure at B. All right, and we know also what the head losses are, which are the energy losses. So when that water flows through the pipe, some of the energy is going to get burned up from friction. So there's 20 feet of head loss going from A to B. So the water is flowing from A to B, like that. All right, so let's first figure out how much energy we've got at A. I think we did this already, but why don't we just run it again? So get the total energy at A. Remember, to get the total energy, what you do is you convert everything into feet. Okay? So you want elevation head, pressure head, and velocity head. Elevation head is just the number, the elevation above sea level or whatever your datum is. Your pressure head, to get that, what you do is you take 2.31 feet per psi. And then your velocity head, what you do is you take whatever the velocity is, you square it, and you divide it by 64.4. Okay. So what you want to do then is get everything converted, because everything has to be in feet so you can add it up. If you don't convert everything into feet, you can't really add the numbers together in any sort of meaningful way. That was given. It's just listed.
Gotcha.
Everybody getting to 432 for the total energy? You all right? All right, so 432 feet. That's how much energy you've got to work with at A. Now what you want to do is track what happens with that energy as the water goes down to B. That's the idea here. So let's see what happens. Now the first thing that happens is you got 432 at A, but then you got head loss that occurs between A and B. You got 20 feet of head loss. Okay. So what's going to happen is you're going to end up with some energy at B that's less, and that's 412 feet. And that's what you got to work with at B. Yeah, question there?
Yeah, if the elevation is 200 feet and the elevation at B is 120, why is that? Well, like, I mean,
Oh, it's just the friction of the water when it's flowing in the pipe. So the head loss is just friction. You're pushing the water through the pipe, and on account of how rough the pipe is, there's a certain amount of friction that happens. And that takes energy out of the water. That's what the head loss is. It's got nothing to do with the rock. It's just the water rushing through a pipe that's dense and, all this stuff.
so how do I know that the head loss is?
I just told you on this one. Now, we'll get into ways to calculate it later. But for now, we'll just say it's like.
Okay.
Right. All right, so what we got left at B is 412 feet. So that's the energy at B. Okay. Now let's see what's going on at B. So the first thing you do is you start at a thing you know, and I know A. And then the second thing I do is I see what happens between A and B, and what happens is I lose 20 feet of energy. So now I know how much energy I've got at B. So now I'll analyze B in a little bit of detail here, okay? That'll be the next thing that I'll do. So at B, I know some things here. Okay, I know what the elevation head is. It's what, 120, is that right? Yeah. So I got 120. Okay. I don't know what the pressure head is, right? I don't know. So I just have to put a question mark in there. And then what's the velocity head at B going to be? It's that velocity, right? Because that pipe isn't changing size from what I can see. So there's nothing going on there that'll change that velocity. And I can just square that and divide it by 64.4, but I don't even really need to do this. Or, whoops, yeah, 64.4. Yeah. That'll just come out to be a foot. That's another reason why velocity head is often ignored. One is it's small compared to the stuff you're doing. And two is, often if you got a single pipe at a single size, the velocity head at one point equals the velocity head at the other, so it just cancels out anyway. Okay? So a lot of times in this kind of water system stuff, they just ignore it. It's just not that big of a deal. All right. So what we've got now is we know that we got 120 feet elevation and 1 foot of velocity head. And then we got 412 is 120 minus plus pressure head plus 1. So what I can do here is I can get 121 and subtract it from 412. So that's 312, 381. Is that 381 feet? I think. No, 281 feet. My bad. Yeah, 281. $291? Yeah, I'm having problems here. Okay, 291. Good thing I've got an eraser. Okay, there we go. All right, so that's the pressure head at B. And so what's the pressure at B going to work out to be? If the pressure head's 291 feet, how much pressure? Yeah. Okay. So that'll work out to be 126 psi.
What was the last step there?
Last step is to take that 291 and convert it into pressure. So you got 291 feet, and you know there's 0.433 psi per foot, and that'll get you to 126. So that's the last step. So you got to have the pressure in feet so you can add it to elevation. But if you want to know what the psi is, you just convert it back with the 0.433. That's all you got to do. Okay. What's that? Yeah. Back here? Okay.
So the 412 is the head loss?
412. The head loss was 20.
412 is the energy.
Oh, yeah, 412 is what's left over after the head loss. So we started off with 432 at A, and then we subtract off the head loss, and that gets us what we got at B. Okay. And then we use that 412 and see how it's divided up between elevation and pressure and velocity. Okay. All right. And then we convert what's left over for pressure head back into PSI. All right, now what's happening here in this system is there's head loss as the water flows from A to B, but it's also dropping. It's going downhill. So you pick up some pressure on account of that downhill drop. Okay. So even though there's head loss, there's more energy gained from going down the hill than there is, or more pressure head gained from going down the hill than there is lost in head loss. So the pressure ends up going up. All right, now I actually like to put these into a chart because it just helps me organize everything. So I just make a chart that looks like this. You've got kind of a version of this on 103. It just helps me get everything organized. So everything that I'm putting into the chart goes into the chart in feet. That way I can add it. So what I had there was 200 feet of elevation. And then I had 100 psi times 2.31 feet per psi. So that got me 231 feet. And then I had the 8.025 feet per second squared over 64.4, and that was 1. So when I add those three things together, 1, 2, 3, what I get is the total, which is 432. Okay, then I subtract off the 20 for head loss and I get 412. And then I look at what I've got on this side. I still have 1 foot of velocity head, and I have 120 here. And here I just don't know what I've got. So that's how I would set that up if I were working through this like a chart. And that's usually how I do this. So I kind of have a pattern to this. I work down to here, then I work across there, and then I kind of bring those together, so to speak, like that. Okay. Yeah, question?
So the 64.4 on the bottom of the velocity head is a constant, right? Is that the number you, okay.
You know, yeah, it's on the formula sheet. What it is, it's 2 times the acceleration due to gravity, but not that you know, it's 64.4. It's on the formula sheet. Okay.
As long as it's the same one every time.
Yeah, that's the same one, yeah. And a lot of times we ignore velocity head anyway. Okay, so that's how I'd actually work through that. I just do a chart because it's just easier for me, okay? And then once you have the chart filled in, now remember, everything in the chart has to be in feet, okay? That's one thing you want to remember. Okay, so that's feet, this is feet, everything is, okay? And that way you can add stuff up together and do those kinds of things. Because if they're in different units, you can't really add them. It doesn't mean anything to add things that are in different units. And then the last thing you would do would be to do that conversion, you know, as we did earlier. So you just take the, whatever the, first do the little bit of arithmetic there. So actually, I guess it's algebra. You got 412 is 120 plus whatever that pressure head is, plus 1. So 391 is the pressure head. And then you take 391 feet and multiply that by the 0.433 psi per foot. 291, thank you. Oh, I have trouble with that. And that comes out to be the, what is that, 126 psi? There you go. So that's how I'd actually work this thing out in a fashion like that. Okay. So we're good with that? Okay. So why don't you, if you like, try that approach there. Let's look at this one here. We're going to ignore velocity head on this one, which is a fairly common thing to do. So we have an open reservoir there, and we're just going to feed a fire hydrant. You've got the elevations given. Let's find the pressure in the hydrant. We know the head loss will be 24 feet when the water runs down. We're going to ignore velocity head. That's going to be our starting point up at the top. What's the pressure up there, do you suppose? Right on the surface of that tank. We're going to ignore atmospheric because we're doing gauge pressure. 0, yeah, okay. So the pressure at the top of that tank is 0. It's gotta be coming up with about 31 PSI, something like that. When they do those, flow tests on hydrants, how low do they draw it down? What's up here? See, that's just open, that's just got zero pressure. See, the 197 is counted at once right here. I don't want to count it a second time. Just put it in there once. And so the pressure, the elevation there is 497. There's no pressure. All that energy is in elevation. So we pump the water up and they use the energy. That's a zero. Yeah. There isn't it. It's zero. This is open. It's like an open storage.
So literally like, so once I find out what, and then also between some 197 and 124.
Yeah, you're just gonna, it's gotta be snapshot of one location, and you're gonna be at the top.
That's what they
That's
told
the
us.
place.
And then also between 124.
Yeah, start there,
yeah.
because you know the elevation is 497. And there's no pressure, that's zero. Yeah, well, yeah. Total energy. Right.
And then like, pressure also travels down here, that's why it's 431.
Yeah. There's gonna be pressure down there, there's all these water sitting there. It's not pressure at the top, it's all elevation. So the next thing you look at is the headline. Yeah, well, you give them the headline.
Pressure head and the velocity.
Well, what you're doing, you're just finding how much energy you've got to work with. You've got 473 to work with, then you're gonna look at where it went. The elevation there is 401.
Right.
That goes there.
Oh.
I guess it just,
You're gonna ignore velocity and and so now you can back into how much you got to go to air pressure.
Yeah, I can solve for X.
Yeah.
So 72.
Yeah. So you can convert that back.
But you need it.
if I don't know what's going on.
This one.
How loud it is.
This one?
Yeah. Because that's.
Is that what it's asking?
Yeah. You know, but
Yeah,
it's
it's
pressure. Normally you get pressure.
On the other one, because there's no tank.
So.
I didn't know it neither did James. She gave it to me, put it in a speaker. He told us to read, he gave us these.
Doing all right? So this is just a method here. So what is this, 473 or something? 497. 497, there's no pressure head. We're ignoring velocity head. So there's 497 all told. We take away 24 in head loss. So what we got here is 473 left over. The elevation at the hydrant is 401. We're ignoring velocity head. So we got a total of 473 and we take away 401. So that leaves 72 feet at the hydrant that is left to go into pressure head. Okay. So when I'm doing this stuff, I think of it as being kind of like accounting, except I'm doing it for energy instead of money. But I've got 3 accounts: elevation, pressure, and velocity. I've got everything in elevation here. So the total amount of money I've got, or energy, however you want to look at it, is 497. I burn up 24. I spend 24 bucks. I've got 473 left. I know I've got 401 in the elevation account. So what's left over for the pressure head? 72. That's kind of how I think about it. It's just like accounting, except you're accounting energy, not money. Okay. So if you got 473 total and you got 401 of elevation, it's got to be 72 left over for pressure. Okay. And then you just convert the pressure back into PSI. So 72 feet.
31.2.
Yeah, something like that. Yeah, 0.433 PSI per foot. I think that's it, right? 31.2.
Yeah.
Okay. Thanks. Okay. Good deal. So there you go. You all right with that? Okay. Good to go. So no class Friday, right? Okay. And I'll try to get those answers to that review posted in Google. And then we'll just cover that review a bit on Monday. We'll probably do some new stuff on Monday too. Then I'll have test on.
You bring it through next time.
All right. Very good. Actually, no, they're pretty good. They make good food.
Yeah, they do.
You gotta wait for it.
Right. Yeah, for the price. Yeah, you can't beat the price.
I actually went on up for stuff to go before and then come back and got it, like go back down to my office and wait and come back.
From the restaurant?
Yeah.